implicit differentiation here. I want to derive everything. I want to find dy dx. I want to derive everything with respect to x. So, first term, I'll do a color code again. Oops. Oh no. Alright, there we go. So, first term's derivative is 3x squared. Next term derivative is product rule, so it's first function, second function. So it's plus derivative of the first, which is 2x, times the second, which is y, plus the derivative of the second, which is y prime, times the first, which is x squared. Now I'm off to the green one, so I get plus, I get power rule, 8y, and then don't forget the chain rule on the inner function, and I showed that in a little bit more detail in 3a, y prime, where that's dy dx. And then it winds up being equal to derivative of 6 is 0. So I am going to group the, group the y primes together. And I'll actually factor it at the same time. So I'm going to have y prime times, I'm going to be left with an x squared plus an 8y. Close the bracket. And now I'm going to take, I'll do it in green, I'm going to take these two terms and I'm going to move them over to the right side. So I get equals minus those terms, 3x squared minus 2xy. And now I'm going to divide by the brackets because I want to get y prime by itself. I'm not going to show, I would just write this in here and in here. And then what that gives me is that these cancel. And I get y prime equals the top, which I'm gonna, I'll do it all at once. So what I do is I notice with this thing that I could actually pull out a negative from both of these and write plus. And I'm gonna actually move that negative out to the front of the fraction. So what I get is a negative fraction bar, and then these guys are positive, so I get 3x squared plus 2xy. And in the bottom I get what's in these brackets right here. So I get x squared plus 8y, y prime.